In our previous video, we learned that the word mole is a name for a specific number, and that number is 6.022 times 10 to the 23rd power. So if we have 2 moles of apples, then we would have 2 times 6.022 times 10 to the 23rd power apples. Or if we had 10 moles of oranges, we would have 10 times 6.022 times 10 to the 23rd oranges. Always remember that the word mole only means a number, and a very specific number, 6.022 times 10 to the 23rd. Okay, now we know what a mole is, but why is it important? What is it about the concept of the mole that makes it useful in the study of chemistry? To answer that question, let's go back to the periodic table and look at the element carbon. The element symbol is a capital C. Its atomic number is 6, which means there are 6 protons in the nucleus of every carbon atom. The number below the C is the atomic mass unit number. The number is written with the letters AMU after it, which stands for atomic mass units. This number is very useful in chemistry. Watch this trick. If you erase the AMU and write in grams, you have the weight of 1 mole of carbon atoms. 1 mole of carbon atoms weighs 12.011 grams. At this point, we are not going to try to understand why this works. You can look that up later. For right now, we just want to make sure that we know how it works. So let's try another example. This time, we will choose the element iron. The element symbol is capital F, small e. The atomic number is 26, which means we have 26 protons in the nucleus of every iron atom. And the AMU number is 55.845. We will now erase the AMU and replace it with grams. So 1 mole of iron atoms weighs 55.845 grams. Let's try one more. This time, let's select the element aluminum. The element symbol is capital A, small l. The atomic number is 13, so there will be 13 protons in the nucleus of every aluminum atom, and the atomic mass unit number is 26.982. Okay, so how much does 1 mole of aluminum atoms weigh? Well, we take the AMU number, and once again, we erase the AMU and we write in grams, and we have our answer. 1 mole of aluminum atoms weighs 26.982 grams. Now we know that 1 mole of aluminum atoms weighs 26.982 grams. We also know that the word mole is just a name for a specific number. Let's plug in that number. So there are 2 ways to make this statement. We can say that 1 mole of aluminum atoms weighs 26.982 grams, or we can say that 6.022 times 10 to the 23rd aluminum atoms weighs 26.982 0.982 grams. You can say it either way, but it's easier to say the word mole than it is to say the number, isn't it? Now let's use what we've learned to help a student prepare a lab experiment. Her professor wants her to prepare 1 mole of carbon atoms and 1 mole of copper atoms. How does she go about doing that? Let's start with carbon. We first need to determine how much 1 mole of carbon atoms would weigh. So we go to the periodic table and we look up the AMU number of carbon. Then we erase the AMU and write in grams. So the weight of 1 mole of carbon atoms is 12.011 grams. Now she needs a source of carbon atoms. This is activated charcoal. It is made up of only carbon atoms, and we will assume that it has no contamination from other substances. Now the question is, how many grams of activated charcoal do we need in order to have 1 mole of carbon atoms? Remember, activated charcoal is pure carbon atoms. And we know that 1 mole of carbon atoms weighs 12.011 grams. Therefore, if we measure out 12.011 grams of activated charcoal, we will have 1 mole of carbon atoms. Well, we're close, but we need a few more carbon atoms. How about if we take this lead out of our pencil and put it with the activated charcoal to help us get to 12 grams? But can we do that? Yes, we can, because it's really not lead in your pencil. It's actually graphite, which is also 100% carbon atoms. We now have 12 grams of carbon atoms, but we still need 11,000th of a gram, but that will be difficult to do. So we're going to round off the number to 12 grams, and that will get us very close to 1 mole of carbon atoms. What you see on the scale is 12 grams of pure carbon, which is very close to 1 mole of carbon atoms. And if we know that we have 1 mole of carbon atoms, then we also know the actual number of the atoms. It would be 6.022 times 10 to the 23rd atoms. Now let's prepare the copper. We go to the periodic table and find the AMU number for copper, which is 63.546. We then erase the AMU and put in grams. So 1 mole of copper atoms weighs 63.546 grams. We will round off this number to 63.5 grams, which will make it easier for us to weigh the copper. Now we need a source of copper atoms, and we will use simple copper wire. We begin to put the wire on the scale. Now we have 62.6 grams. We need 63.5 grams, so we'll cut another piece, which gets us up to 63.4 grams. And we place another piece on the scale. It puts us at 63.6 grams, so we need to cut a smaller piece. and that takes us to 63.5 grams of copper wire. There is now 1 mole of copper atoms on this scale. If we were to state the actual number of copper atoms on the scale, what would that number be? Now it's time for a CAT, a comprehension assessment test. Let's begin. Question number 1. What is the weight of 1 mole of oxygen atoms? Question number 2. How many protons are in the nucleus of every oxygen atom? Question number 3. An element has an atomic mass unit number of 10. How much would 6.022 times 10 to the 23rd atoms of that element weigh if you were to put them on a scale? Question number 4. 2 moles of helium weighs about Question number 5. 2 moles of an element weighs 30 grams. What is the AMU number of the element? The atomic mass unit number, stated in grams, tells you the weight of 1 mole of the element. The atomic number tells you how many protons are in the nucleus of every atom of that element. If an element has an AMU number of 10, then 1 mole of atoms of that element will weigh 10 grams. 1 mole of helium will weigh about 4 grams because its AMU number is 4.0026. Therefore, 2 moles of helium will weigh about 8 grams. If 2 moles of an element weighs 30 grams, then 1 mole of that element must weigh 15 grams. And the AMU number of an element equals the weight of 1 mole of that element stated in grams.